Okie dokie, artichokey. Let's get into another worksheet. Worksheet 7.3-4, Independent Samples t-test. Again, with the double worksheet. Oh well. So here are those useful codes again to get those critical values. They're all the same. And here is a long, ugly looking equation to do pooled standard deviation. So we have the degrees of freedom for group 1 times the standard deviation squared, so it's basically the variance, plus degrees of freedom for group 2 times the standard deviation of group 2 squared, so it's basically the variance. You're going to take both of those, divide by the degrees of freedom for the independent samples, which is all of it basically, and you're going to take the square root of that. So it's ugly, but at least all you have to do is plug in all the information. Then we also have pooled standard error, which is the standard deviation squared divided by the number of people in group 1 plus the standard deviation of group 2 squared divided by the number of people in group 2. And you square root that whole thing. And then to do our t-statistic, it's the same that we've been looking at basically. You take sample mean of 1 minus sample mean 2 divided by the pooled standard error now, rather than just the standard error for one sample. And to get Cohen's d, we take sample 1 minus sample 2 divided by pooled standard deviation. Okay, let's get into it. We want to know about the dieting thing. We have 8 low fat, 14 low carb. Low carb have 3.5 pounds of weight loss. Standard deviation of 3.2, low fat, 2.8 pounds, standard deviation 2.1. It's just a lot to read. I've been filming a lot of these videos today. Let's just keep going. Okay, so we have a lot of stuff we have to put in. The sample mean for group 1, the sample mean for group 2, the sample mean for, standard deviation for group 1, standard deviation group 2, the number of people in group 1, number of people in group 2, degrees of freedom group 1, degrees of freedom group 2, big N, which is the number of people in group 1 plus number of people in group 2, and the degrees of freedom, which is big N minus 2. Woo! All right, now let's calculate the pooled standard deviation by copy-pasting that lovely formula from above. And now that all of these are defined, we should get a pooled standard deviation value. We do. It's 2.863477. Okay, let's keep on here. Let's go and get our pooled standard error. Let's see, we have 1.13255554. Great. Okay, so now let's actually do all the hypothesis testing stuff. State the hypotheses. We're going to say that group 1 is equal to group 2 and that it's not for the alternative. Testing at 0.05, independent samples t-tests. We are getting our critical values. We're doing a two-tailed because they normally are. You can do a one-tail independent, but I don't think I make you do any of that. So let's go and get our two tails, 95. So we use that 0.025 because we're looking for that proportion down here and this proportion up here, that 0.975. And we are looking for those standardized values that correspond with right here and right here. And if we go and get those, we see negative 2.09 and positive 2.09. Now let's go and compute our test statistic. Look at that, 2.56. Do we get to reject? Yes, indeedy. You could see it here, spoilers. So here are the critical values, and our t-statistic was outside of that into the critical region, so we get to reject the null hypothesis. Hooray. But what is our Cohen's d? Ooh, like 1. That is a full standard deviation of difference between the two groups, so it's pretty big. All right, so we get to reject that null. So let's also construct a 95% confidence interval for this example. We're going to take our critical values, because now when you create a confidence interval for sigma unknown, so you're using t, our level of significance is going to be the t value, not the z value. We're going to multiply the pooled standard error that we calculate above, which was at 1.13. And if we multiply standard error versus the level of multiplying the level of significance you want, you end up with your margin of error. And in this case, it is negative 2.36 and positive 2.36. Now you might be wondering, why are there two values? Because our critical values, there was two values saved in that object, that critical values object. So you actually get the plus and minus, which actually makes your life easy because you just take the difference between the two groups. Remember, we're looking for the mean difference. So sample 1 minus sample 2, there was 2.9 pounds of difference between them. And we are going to add the margin of error. But remember, our margin of error is two values, the positive one and the negative one. So Ta-da! It gives you the confidence interval. You don't have to do plus margin of error minus margin of error because they're already both in there. So we get a confidence interval between 0.54 to 5.26. And this also confirms what we already concluded, that we reject the null hypothesis because there is no zero in there. Hooray! So low fat better than low carb, apparently, at least according to this example in this sample. Okay, number 2. So this is, let's find out which of 2 study methods results in a higher test grade: reading and highlighting a textbook, so we're going to call that TB, versus doing practice problems on a worksheet. We're going to call that PP. Oh, when you say this stuff out loud. We form 2 groups, and that is our independent variable. By randomly assigning the students to the TB group, we have n equals 16, or to the PP group, n equals 6. The TB group had an average score of 14, standard deviation of 2. PP group had an average score of 17, standard deviation of 1.5. The pooled standard error is 0.79. I'm going to just give it to you so you don't have to calculate it. So test at 0.05. Is there a significant difference, and which method works better if there is a difference? So let us put in all of this information. But remember, this time you do not have to calculate the pooled standard error, and I'm not asking for effect size, so you don't have to get the pooled standard deviation either, but you could because you have the formulas. So put all that in there. So let's see, actually, what are our degrees of freedom? 20, okay, just curious. So we're going to say group 1 is equal to group 2, group 1 is not equal to group 2, 0.05 significance, independent samples t-test. We're going to get our critical values. And we have this time negative 2.08. Oh, we have the same degrees of freedom as before, don't we? Let's just make sure, because remember I told you if you accidentally don't refresh and don't name these things different things, you might get into trouble. Okay, so they both examples just had the same degrees of freedom. So we have the exact same critical values, making our life somewhat easier, I suppose. Oh, look, here was the confidence interval for the last one. Ta-da! Okay, so now, here's our drawing for this one. Always a spoiler, I'm sorry. Oops. Bring it back, there we go. Okay, so we have our critical values. Let us just calculate our test statistic. We have negative 3.79, basically negative 3.8, and that is out here in our critical region. We get to reject that null hypothesis. All right, so which one is actually better though? Is the textbook better, or the doing practice problems better? Well, we see that if we take the mean of sample 1, which was the highlighting and reading the textbook, minus the, wait, hold on, sorry. So they had a score of 14, and we had a score of 17 for the people who actually did practice problems. And if you take that difference, it is negative 3. So which one then is doing better? Sorry, negative 3. We know that this number is smaller than this number, so we know that the practice problems group did better. Okay, construct a 95% confidence interval around this. So again, we just take our critical values, which we already had. We have the positive and negative one now. And we multiply it by our pooled standard error, which I just told you in the example, which was 0.79. You go and do all of that good stuff, and we end up with a margin of error of negative 1.65 and positive 1.65. So we are just going to, again, take the difference between them because we want to create a confidence interval around the differences. And we add and subtract that margin error. We end up with negative 4.64 and negative 1.35. So they're both negative. They're both on the same side. There's no zero in there, so it confirms, again, what we already decided, the rejecting the null hypothesis. And in this case, again, doing practice problems is better than just reading the book and highlighting. That is not an effective study strategy usually. Okay. Here is our confidence interval, our 3 in the middle, and that negative 4.65 and negative 1.5 or 35. Okay, next one. I can't show it to you. It's okay, my face will just hide it. My shoulders. Okay, number 3. Let's say we want to find out if people who live on the east side of Austin experience more or less asthma-related complications than the west side. I-35 divides east and west in this example. The average number of asthma-related complications for those on the east side is 15, n equals 20, while the average for the number on the west side is 6, n equals 15. Their pooled standard error was 3. Is there a significant difference in asthma complications between East and West residents? Test at 0.05. Let us see. So we have our sample mean for the first group. 15 people on the east side went in for asthma-related complications. 6 people on the west side. You might be wondering, why did I do this example? Like, I research asthma stuff, and we're looking at the spatial distribution, and just saying east and west is a little black and white, but it kind of is. Like, on the east side of Austin, it's known to be a little bit lower socioeconomic status and higher rates of poverty and higher rates of minorities who also are known to have higher rates of asthma. So we're going to test if this is a significant difference. And also the west side of Austin is associated with, apparently, the rich people. Okay. So we have a pooled standard error of 3. We have 20 in the first group, 15 in the second group. And we have our degrees of freedom for the group 1, degrees of freedom for group 2, the big N, degrees of freedom total. Okay, so mu1 does not equal mu2. mu1 does equal mu2, mu1 does not equal mu2 for our hypotheses. 0.05 independent samples. Let us get our critical values. And this time we have negative 2.034. Is that the same? No, slightly different. Okay. And let's go and calculate our test statistic. We have 3, and it's definitely going to be significant. So here we have that 2.034 critical value, and we have our test statistic here. It is definitely in that critical region, so we get to reject that null hypothesis. So let's create a 95% confidence interval around that. We have our critical values. We have our pool standard error, get our margin of error, which is negative 6.1. And now we are going to add that, and we have our 2 values in there already, so we don't have to add and subtract, to the difference between sample mean 1 and sample mean 2. What was that difference? 9. So let's see. So the true difference is somewhere between 2.89 or 2.9 to 15.1. So again, confirms what we already decided. We're going to reject that null hypothesis. There seems to be more people who have asthma-related complications on the east side than on the west side. Well, alrighty, that was independent samples. Hope that helped. Give it another go. Practice. Go have fun with it. And I will see you in the next one, the dependent samples t-tests. See you later. Bye.